Hello, let's solve some Leetcode medium today in Python. Um, our first problem will be simplified fraction, maybe, or let's start from here. So design a stack with increment operation. Yeah, design a stack that supports increment operation of its element. Yeah, let me copy the whole um, URLs. All problems we have for today, just for my records. Design a stack with increment operation. Design a stack that supports increment operation on this element. Implement the custom tracks class, custom stack class, custom stack, max size, initialize the object max size, which is maximum number of elements in the stack, push add X element to if stack has not reached the max size. What if pops return top or -1 stack is empty, increment the button if there are less than element. But what happens if we reached max size? It's not adding. Uh, I guess we will find out. All right, so I will initialize data. So we need increment k val from the bottom of elements to val, which is pop, push. Everything seems simple. So what we're gonna do, we gonna first we're gonna add data, and it will be just a list. Then we gonna initialize size, which is max size. You know what? Let's call it max size. And then on push, we push self data push x. On so do we have to check? Okay, let's check if self data size, if length self data size more or less than self max size, we push. Then if length more than 0, we pop. Return pop. Else we return -1. Increment, it's pretty easy. So bottom, we have to go from the so if we add in if we add in like here, we add in elements to the stack, right? So if we are adding 1, 2, 3, 4, 5, so we push 1, we push 2, we push 3, we push 4, we push 5. So we push 1, we push 2, we push 3, we push 4. So this is beginning, this is end, right? I guess so. And bottom elements means from the end. So for E in length of in range, maybe range, there is something like if k element is a stack implement. Okay, so let's define L as len of self data is if k is more than L, we assign k equal L. So it will be not data, we will not go out of array, and then what we're gonna do, we're gonna iterate from L, so we have to five. Okay, so we start from so this is L, this is K, so we start from K. Okay, increment the bottom k elements of the stack by val. If there are less than k elements in the stack, increment all elements in the stack. So we start from L minus K, and we end by L. And what we're gonna do, we gonna sell data. I will just add value, right? List is not has not a list has append. Wait, but in this case it will be different, no? Push one. Okay, so yeah, let's let's log a little stuff. So I would log print push, because it's hard for me to understand. Uh, yeah, so we push one, we have one. We push two, we have two. We push three, we have. We push two, we have two. We push two again. So we one, we push two, then we pop. Oh, because of return. Yeah, because of return. Yeah, let's define return as -1. We assign return this guy. We print self. We print return self data, and we return red. Okay, so we push one, we push two, we pop one, we pop two. Yeah, pretty much. We push two, we push three, we push four. We pop three. What is this? What is it? We did increment. Oh, we did increment 5 by 100. And there is a saying that it has to be we after 4. Okay, so we can say in, increment value and self data. Yeah, everything seems working well. And the only thing is how, yeah, how, like, I think I messed up with incrementation range somewhere, and I can figure out how. So increment, I need key, right? How many? Yeah, kind of nice. Yeah. 2. So 1, 2. But it has to be from the bottom or from the top. Increment the bottom k element. This is what I did. This is top. This is bottom. I increment bottom 2 by 100. What is going on? Then, so I increment 5 by 100. Oh, 5. Okay, but I have only 3. Therefore, I will go in range k. L minus k. That's the problem. See, this is 5 and I missed 3. So if more than L, okay, let's do this. Okay, now I incremented 5. Now I increment bottom 2 with 100. This incremented top 2. Yep, so we do from 0 to k. Yeah, from 0 to k. Okay, let's sketch some corner cases. I bet there I cannot. Oh no, no corner cases. Beautiful, nice. Yeah, so it was pretty easy to implement with because Python doesn't make a difference between stack and array. It's the same for Python. So I wonder how it could be implemented. It's like implemented in array, like in C++ array, and kind of be tricky. Much more code. But yeah, that was nice. Now let's submit it one again for better runtime percentage. 22. It's not bad, but yeah, I wonder where what is faster code, how it does look like. Okay, let's see. Let me copy this here in my code. Very nice. Yeah, let's see how fastest implementation look like. Oh, they created, okay. Items and increment, and why they're two different? We are storing items and increments separately. Question is why we are doing that. Okay, this is nice. Why they're storing? Why we can't just increment? I don't understand. Okay, lazy incrementation. Why we need lazy incrementation? Use additional array to record to increment value. Increments for all elements. You should increment when popped from the stack. So we can accumulate the increment for the bottom elements and pop them. Yeah, I know. Why? Lazy increment is important to learn from Excel. Yeah, crazy stuff. It's like lazy implementation. Yeah, but why? Yeah, I don't understand why to do it, but yeah, lazy implementation it is. This is interesting. All right, yeah, let's go for another one. Maximum ice cream bars. This sounds like fun. It is yeah. At this store, there are n ice cream bars. You're given the cost and length of length n. Okay, so we have a cost. We have 7 coins, and 0, 3. So we sort total array coins into buy working in any order. The maximum number of ice cream bars the boy can buy with coins. 7 coins to spend. So we sort them and we buy cheapest first. This is what we need to do. So we can say cost equal sorted costs. and then while points, I'm automatically writing count. Too much counter. Too much counters, yeah. It's like I was a lot of writing counters, now I write counter just like right away. So if y counter is more than 0, we pop 1 from costs, and then the and we need the result, right? So we need to calculate how many bars, called bars, and we return at the end. I think I can just iterate for bar in C, right? From smaller, I can say if bar cost, okay, bar cost less than coins, less than equal coins, we remove it from coins, right? Bar cost. Else we return, and here we add bars, we increase bars, so we bought this one. So this is like shopping bar, and we return bars. Or we can break. Yeah, that's it. Yeah, piece of cake. Let's see. Two. We did not sort it. Why did we? Where unique cost of the cost is binary search maximum number of ice cream, because the total ice cream we can afford. Sort the ice cream based on the cost, then greedily buy the cheapest ice cream. Yeah. Okay, so this is what we do, and it's 82%. N log n. Use binary search maximize number of when of course the total ice cream we can afford. Use a list as a dictionary. We calculate cost frequency y. Cost frequency costs. Minimum between cost frequency and coin. Oh, okay. It's like we have 2 of 1, right? So we can say we bought them right away. And we have to, we don't have to go through entire thing, right? Is this what it's doing? Java. Greedy approach. Yeah, this is what we did. Solution 1. Solution 2, using bucket sort to bring time complexity to 1. Bucket sort is good in this problem because of constraint. Okay, so we just calculate coins by price and price by count. Okay, yeah. Isn't that beautiful? I really like it. So this is good for bucket sort. So we created like entire array, and we calculated how many of each things in the entire array. Then we enumerate entire array. 10 of 5. Wow. This is, yeah. All right, let's move to another one. A length of longest alphabetical continuous substring. The alphabetical continuous string is, yeah, alphabetical, in other words, in any substrings. Okay, this is nice. So, for example, ABC is alphabetically continuous string, as ACB are not. Given a string consists of lowercases return the length of longest alphabetical continuous substring. Yeah, so this is AB, BA, no, AB, so they must, okay. Then ABC or DE, it's 5. Okay, so what we can do, how about um, we have 2 pointers for this, right? We have L pointed and like this. And if they are alphabetical, we increase and check if this is alphabetical. Uh, we create some variable like result, we initialize with this. And as we move in through array with right pointer, if they're alphabetical, we increase right pointer. They are not alphabetical, we decrease left, increase left. So first is AB increase. What we're gonna do? We're gonna if S left I think it should be or D. Um, if right minus or D left equal 1, we have a we assign res max res. We increase the result because we have increase. calculate, we make sure that we have right minus left here. Else we just increase L. We increase R here. And loop will be while R less than length of S. Like this. And at the end we return this. It looks good. Invalid syntax, while, yes. Let's calculate L here. Minus 1. Oh, just L. And while. Cannot access variable R. Oh, yeah. So, right elements. We have 1, 0. Cancel variable res. Oh, and res is 0, 2. Or site minus 1. Out of range. So we started from R. Index out of range. So we did L. So we cannot increase L indefinitely. I think this is L what is doing. So if so this should be R minus 1. Which is not correct. So let's walk through it again. There are two continuous, right? So we increase in R and we checking if R continues with this. No, not. It's not continuous. That means we have to decrease. They are not continuous, so it's breaking the entire thing. If they are not continuous, we have to assign L with R and R with L plus 1. So we're jumping right here. And we trying over. We check it's not. We jump in here. We trying over. It's not. Jumping here, it is. Checking here, it's not. And it should return correctly. Let's, we should run through the second case. Yes, this is what I'm saying. 0, 1, 2, 3, 4 give us +1. No, maybe not. So why this is not working? Let's go and try this. So we have left pointing here, right pointing here. So continuous, increase, continuous, increase, continuous. This is indexes 0, 1, 2, 3, 4, continuous 4, and we select 4 minus 0, return 4, but why is 5? Because length is 5. So I can say that let's say calculated length will be and if left equal if left equal more, okay, so 0 else like this, and we have calculated length. And r equal L minus 1. Yeah, I'm totally trying to pass this H case and just don't think about it because, yeah. But let's see what how it's gonna work with other H cases. Wrong answer. Okay, so we have just one Z and we output -1, but which expected 1. Another H case, here we go. So we can say if L equal 1, just return 1. LV -1, expected 1. Okay, so it's probably, if it's 0, we should return 0. Do you think? Hmm. Okay, let's try it one. No, I cannot, obviously. Oh, this is why. No, I have to max between this and this guy. And hmm, use test case. And it's only 14 test case. Okay. So AWY. So return uh, 1 if res equal -1, else return res. So how there is a RP? No. What is this? Is where is um yeah, this is a weird stuff. Like, can I have 0 here? Why do I have to do -1? So why have to increase res here? Res is just res. It doesn't matter. It can be -1. I think there is a something. Can I just say right minus left and that's it? Yeah, apparently I cannot. So if res is 1, we increase, we assign left to right, and we start over with a new function, because this is, if we have something breaking, right, if we have something breaking right here, we have to start over. There is no point for us to uh, there is no point for us to continue um, dragging left pointer behind and do something, right? So, but my question is, why? So they continue. Right minus left equal 1. So I calculate right minus left plus 1, and else right minus left, and calculate result, increase right. Left, and otherwise left is right, right is right plus 1. It doesn't matter at that point. We can say left, right, right, right plus 1. Oh yeah. So I don't need this entire thing. I can just say right to make it even more faster. Yeah, pretty much. Yeah, it was a good task. Let me copy my code to my records. And we will see how people solve it. I want to try to do this thing. Oh, even slower. Okay, that's fine. Let's see faster code. Yeah, so new D, if new D plus current directory is 1. Yeah, it's pretty much, but we iterate from the end. We iterate reverse extreme. We start from 0 and we iterate reverse and we calculate if current of D is 1. If new ID equal current of D current of D plus 1. It's pretty much the same. Let me put more cleaner code. I don't understand why it's faster. Yeah, all right. It will be it for today. We have like solving it with 15 minutes, 50 minutes, kind of a lot. Thank you for watching, and I'll see you tomorrow. I'm streaming at 8 p.m. EST, so yeah, join me tomorrow for more Leetcode Medium in Python. Thank you.